The first of 10 conversations in which the late Jacob Bronowsk gives his personal account of the discoveries and philosophies of the 20th century. The program's introduced by George Steedman.
An interview takes you on a journey round the inside of somebody's head. And when Bronowsk had finished his TV series on evolution, we sat down to some conversations about his own evolution, his own intellectual development during that scientific 20th century. And I put forward an idea that an archaeologist in some distant future might dig up our skulls and somehow be able to discern what had been the specific content of our 20th century minds. And so I put the question to him, what would the archaeologist find that identified our skulls as 20th century skulls?
I'll try and look at my skull in one hand of the archaeologist, but I want to hold beside it, say, my father's skull, a 19th century skull, because we need to know not only what is inside the 20th century skull, but what's new in it.
And what was its inheritance?
That's right. My father was not a well-educated man. He was intelligent. He was learned in the Old Testament and its commentaries. He tried to keep up with the news. But if he had been asked to give an outline of what he knew in science, which is what I'd like to start with, it would have been rather muddled. I'll try and simplify it. First of all, of course, my father, my mother, their generation was much engaged with the fact that Darwin had talked about the descent of man for the first time in their lifetime. That was a great shock to the 19th century. It was also a great formative idea for the 20th century. That survived. There is no difference between the shock that my father's skull suffered when it first heard that man is related to the apes, and all the rich fact and legend that my generation, the 20th century, is drawn from that. So that we can put aside as something we shared. In the physical sciences, however, our views are very different in three major respects. I'll take them one by one. First of all, my father, like everybody in the 19th century, believed that, yes, the universe is made out of tiny blobs of matter, which he called atoms. He knew that. But he thought they were the ultimate constituents of matter. He never dreamt that they could be taken apart, and that in taking them apart, the greatest source of energy that man has ever found would be discovered. The second respect in which my father had a picture of the world which is different from yours and mine is this. It didn't occur to him that energy, the stuff with which matter interacts and on which the whole functioning of the world depends, energy, that is light, electricity, all forms of heat, that all those things also were lumpy. Those lumps are not called atoms but quanta. That was an idea which was also unknown in the 19th century. A difficult idea. Seems obvious to us now. Thirdly, and perhaps most sensationally, my father and all his contemporaries were convinced that there is a world out there to be observed, which goes on in its great predestined godlike way, and that we merely peek at that without taking any essential part in formulating its laws. My father thought of the world as being something that human beings were trying to understand, but it never occurred to him that the relations of the world involved the understander as much as the outside world. All that sounds very complex, and it is complex. It's a great philosophic idea. It's one of the three great ideas in which our century differs from the last. It's the idea of relativity. Those are, to my mind, the three branches, the three candles in the candelabrum of knowledge, which are lit in our century and had not even been thought of in the last century. The first of my father's principles was overthrown by the discovery of the electron by J.J. Thomson in 1897. The first time that a particle smaller than an atom was found, much smaller than an atom, almost 2,000 times smaller than even the hydrogen atom, which itself is the smallest of all atoms. The second was overthrown in 1900, when Max Planck, on a famous afternoon, taking his little boy for a walk, said to him, "I have just made a discovery about energy every bit as important as the great idea that Newton had." A wonderful remark, which went down to death in a Nazi torture camp when his son was killed by the Nazis many years afterwards. That's a wonderful recognition by a man of how revolutionary it is. We know it to be so, but he knew it from the outset. Why? Because his idea was that from moment to moment, the universe takes unexpected jumps. He called them quantum jumps.
This is at the very tiny atomic level.
That's right. The quantum is the smallest unit of energy that can take part in a physical action. And therefore it broke entirely with the idea that physical action was infinitely divisible, infinitely continuous, and therefore the future could be foretold in infinitely fine detail from the past. That idea of the quantum, which Max Planck published in the year 1900, is perhaps the biggest single corner between the 19th century skull and the 20th century skull. The biggest single ridge that would be found inside my skull and not in my father's.
So Planck said that energy changes occur in little bundles, little quantum jumps.
And of course that would be a shocking idea to my father, who had become convinced that matter comes in lumps, but had always thought of energy as being smooth. And you know, that opens up a third vista, which of course is the critical one. It opens up the third vista because it begins to make it clear that matter and energy are very much linked together. That idea was not in Planck's mind, and it was certainly not in the mind of J.J. Thomson or any of the people working before then. It was in the mind, or as a byproduct, of a strange, eccentric young man called Albert Einstein, working in Switzerland and publishing for the first time in 1905. He published in that year a number of important papers, but of course the great paper was the paper on relativity. I want to talk about relativity as a scientific concept in detail next time. But I don't think I would want to stop today without talking about relativity as the enormous, powerful social concept that it's become for the 20th century. Einstein was a genius in all sorts of ways, and one of them was inventing that terrible word relativity, which is a bad word for physics, but a marvelous word because it's so open to misunderstanding, to ambiguity, to being applied to situations for which it wasn't invented. It's a word that was on everybody's tongue by the time I was a few years old, because everybody could understand that social relations are relative, the relations between the sexes are relative, religions are relative, the place of human beings in the total scale of nature is relative, and with that single idea, therefore, the coming of the 20th century destroyed the old fixed absolutes. It certainly destroyed monarchies and empires. It was a revolutionary idea in the most profound sense.
It's been a remarkable century, I think, with a stretch of both discovery and the stretch of intolerance.
When we look back now, we think of the century as one in which, my God, They're as intolerant as they were in my father's day. My poor father, who was born in a ghetto in Poland, a ghetto which was afterwards burned to the ground, in which people were tortured and killed. My father would have said at the end of his life, in what have we improved? What, in these three ideas? Who knows about these three ideas? The man down the street, the milkman, the postman, has he ever heard of them? Yes, he has. You see, the most extraordinary thing is that here, on the threshold of the third quarter of the century, we think that all these ideas are evanescent, and yet they've entered into everyone's mind. What I've been saying in these past minutes is now in everybody's bloodstream. That's the most extraordinary thing that happens in a century. Intolerance may march on, but the light goes on quietly in brain after brain, and by the end of the century, we're alight with new ideas.
At the beginning of the century, I suppose we were still really in Newton's universe, which was 200 years old now.
And in a dark universe. George, I'd like to take up this picture of light. It's funny, Einstein wrote a paper about the quantum theory. It was one of his first papers. He wrote it in 1905. And what are now called quanta or photons of light, he called arrows of light. Lovely word. My arrows of desire, as the poet William Blake said. I've only once been back to Poland since I was a small child, to the house that I was born. And you know what struck me about it? It was so dark. We lived in this corner of the ghetto, and it was dark. And I suddenly realized that having moved into the Western world, I had moved into the light. I remember the day that I went to fetch the milk as a small boy in 1918 in Germany, beginning of 1919, and standing in line waiting for the ration of milk. I saw that the newspaper kiosk was covered with illustrated German newspapers, and all the papers carried a picture of an extraordinary man that I'd never seen, who looked something like a Newfoundland dog. Rather big ears, big eyes, face that seemed sort of to flow down the page. And it said Albert Einstein, and then it told about the famous experiment which the Royal Society had just carried out in observing the famous eclipse. I'd never heard of Einstein, but there he was on the paper. And what was it all about? It was about light bending near the sun. And the issue ever since then has been that such predictions in which the properties of light, the properties of energy, the properties of matter, take on a new shape, they are the stuff of which intellectual revolutions are made.
And we've had to learn to think of them as waves and particles at the same time.
Yes, and as part of that, we have had to learn to think that the world isn't just there, but it's there the way we think about it. You see, that very characteristic and telling phrase you've just used tells so much. We have had to think of them as waves and particles at the same time. To which my father would have said, my grandfather would have said, Isaac Newton would have said, what the hell? What does it matter to them what you think they are? To which our answer is, that's exactly what matters to them. That's all that matters to them. They don't know what to think of themselves. The world is made of what we think.
That was the late Jacob Bronowsk in the first of 10 conversations with George Steedman.